Guys, Mr. Donnelly here once again, your favorite and only chemistry teacher. So last lesson, we looked at how to name and write formulas for ionic compounds that contain polyatomic ions. In this next lesson, we're going to learn how to write formulas for and name compounds, ionic compounds, that contain transition metals. Writing formulas for and naming ionic compounds with transition metals is very tricky. It requires quite a bit of math to be able to solve some of these problems. And that's the reason why I have a tendency to teach this lesson last for naming and writing formulas for these ionic compounds. The reason why it's so tricky is because we're using the transition metals, and we can't use the periodic table to determine the charges for the transition metals, because the transition metals have charges that vary. So let's take a look at how to first write formulas for these ionic compounds that contain transition metals. Just before we start that, I'm going to point out some very common transition metals and their ions that we're going to be using in the lesson. So if we take a look over here at the board, we'll notice that I have iron 2+ and iron 3+. I also have copper 2+ and copper 1+, chromium 2+, chromium 3+, and chromium 6+. In addition, I have gold 1+, gold 3+, titanium 3+, and titanium 4+. All of these common ions have one thing in common. And that one thing, well, two things in common, really. Those two things in common are, one, they're all metals, and two, they have varying charges. We can't say the same thing about those ions that we find in groups 1 and 2, those metals we find in 1 and 2. We know for sure, we're definitive at all times about what those charges are. Here, we have to use math to predict what the charges of the transition metals will be. So like I said, the first thing we're going to do is start by writing formulas for some of these ionic compounds that contain transition metals. So let's take a look at one. So I hope you're following along here, and of course you're going to have to take notes as we go. So the first name that we're going to deal with is iron 2 nitride. So let's take a look at how to write the formula for iron 2 nitride. So let's write that on the board first. So we have iron 2 nitride. When you look at this formula that I've written on the board, iron 2 nitride, the first thing you probably notice is this name is quite a bit differently. It looks quite a bit different than the way we named previously. And that's because it has a Roman numeral between the iron and the nitride. That Roman numeral right there, the Roman numeral 2, is very, very important because that Roman numeral defines the charge of our cation. That Roman numeral defines the charge of our cation. So let's first write the symbol for iron, because that's the first step in writing the formulas for these ionic compounds that contain transition metals. So the first thing we'd do here is we'd look at iron, we'd find its symbol on the periodic table. You guys might remember that already, but iron symbol, you're doing this with me as I go. Iron symbol is Fe. Now that Roman numeral that we see there, that Roman numeral 2, represents iron's charge. Remember, all metals are considered to be cations, and those cations carry a positive charge. So 2 represents iron's charge, and we're going to write that just like we did before. I'm going to draw an arrow down here just to remind you where this goes. It's iron 2+. We got our charge for the iron 2+, right? That was pretty simple and straightforward if you stop and think about it. All I did was identify the element, wrote down its symbol, identified the element, used the periodic table to write down its symbol, but did not use the periodic table to find its charge. Instead, I used the Roman numeral 2 to define its charge. Next, I'm taking a look at the anion. Recall that anions are always negatively charged, and we're always going to be able to use either a polyatomic ion chart or our periodic table. In this instance, I know I have to go to my periodic table for 1, from one important thing in the name. That's the ending of the anion's name, "ide." So "ide," right here, tells me that this is not a polyatomic ion. Instead, this is an ion that was formed from nitrogen, from my periodic table. So what I'm going to do here is I'm going to write the symbol for nitrogen. That's N. Of course, you guys know how to do this next part already. We've been doing this for weeks now, right? Nitrogen is in group, if I can remember, 15. That tells me that nitrogen's going to have a -3 charge. So I'm going to go ahead and write that charge in there. So 3 minus. Now recall from previous lessons that all you have to do here to balance the charges out, to get an overall charge of 0 for this iron 2 nitride, is to cross the charges. And I'm going to do that. So I'm going to cross the charges now. So I'm going to circle the 2, bring that down below the N, just as I've done previously. I'm going to circle the 3, bring that down below the Fe, and then I'm going to rewrite my compound in proper form. Something that I noticed that a lot of you were doing when you were answering some of these sort of questions, the crisscross type of questions, or writing the formulas, is that you guys were including charges in the formula. We don't do that. And or you were putting those two ions, the iron for instance and the nitrogen for instance, far apart from one another. That's going to get marked wrong because when we write the formula, we have to show that the two ions are together. So that's what I'm going to do now. I'm going to write that formula so both ions are together and get a correct answer here. So here I go. So I have Fe3 and then N2 right next to one another, N2. This is the correct answer. Notice that I did not include any charges. I did not include any charges on the compound, right? And I have both ions close together to form a balanced overall compound of 0. So here I have iron 2 nitride, iron 2 nitride. All right, let's take a look at another one. We'll move a little faster because I know you guys don't like listening to me talk very much. So here we go. We'll take a look at the next one. The next one we're going to deal with is copper 2 chloride. So copper 2 chloride. A very common compound that we'll use in chemistry class and that you'll see in textbooks and you'll get on worksheets and you'll see in your quizzes. So important that we understand how to work with copper 2 chloride. Same instances before. Let's come back over here and take a look. Copper can take 2 different forms of an ion. It can be 2+ or it can be 1+, right? So the first thing I'm going to do is look for the symbol for copper on the periodic table, right? Copper is Cu. So I'm going to put the Cu in for the copper. Cu. Next, recall what I said before. The Roman numeral 2 stands for the charge of the copper. So I'm going to write Cu2+, carrying that Roman numeral 2 down. Here we go. So the 2+. I've got a correct ion charge on my copper, the copper transition metal, right? Next one, guys, is going to be chloride. Chloride, again, that "ide" ending tells you that you're going to go to the periodic table. If it was "ite" or "ate," you're going to look to your polyatomic ion chart. So here we go. "Ide," periodic table, find it. It's Cl. Cl is a halogen and group 17. Remember that all of our group 17 elements will carry that 1- charge because it wants to take one more valence electron to become like a noble gas. So I'm going to put 1-. Here's the easy part. All we have to do is cross our charges here. And that's exactly what I'm going to do. We've seen this over and over and over again. You've practiced it in class. So that's what we're going to do. Circle the 2. Bring the 2 down. Now recall that 1, I don't have to carry the 1 down. You guys have been doing that. Not all of you, but many of you have been bringing that 1 down and writing it in the formula. Don't need to. Simply writing the symbol represents one of whatever element or ion you're dealing with. Don't need to carry the 1 down. So I'm just going to circle it and stop my crisscross to remind you guys that I don't have to write the 1. So here we go. Remember, I have to write them close together. So I get Cu. I didn't have to bring the 1 down. I'm showing 1 copper by not bringing the 1 down. And I have 2 chlorine. So I'm just going to write Cl2. Here I have a balanced chemical formula with an overall charge of 0. All right? Very good on this one. So let's box this one off. We know this one's right. We'll get 100. Or at least we'll get a one extra point when we actually write this correct answer when we take a quiz. So let's look at the next one. The very next one we're going to do is gold 3 phosphide. Gold 3 phosphide. Gold 3 phosphate. We're going to do gold 3 phosphate. So we'll write that down. Gold 3 phosphate. All right, so again, I have a cation. My cation here is gold. Gold can be found on the periodic table. Those cations are always positively charged. When we're dealing with the transition metals, the Roman numeral there stands for the charge of the metal, or the cation. So let's take a look and write that out. So I got gold, which is Au. Roman numeral is 3. It's 3 plus. I have an anion. This anion, as you guys probably see, has an ending of 8, not on the periodic table, right? Not on the periodic table. How do I know? Because that ending 8 tells me that it is a polyatomic ion. It might be ite. If it was ite, it would also be a polyatomic ion. If it's ide, it's not. So this is phosphate. I know from looking at my ion chart, my polyatomic ion chart, that phosphate is PO4 3 minus. PO4 3 minus, all right? So now what we're going to do is we're going to cross the charges. All right, so let's go ahead and do that. So I'm going to circle the 3, bring it down. I'm going to circle the 3, bring it down. And the first thing I should recognize here is that my subscripts, look at it this way, my subscripts are both 3. 3 to 3 is the same as 1 to 1. So what we can do here is we can cancel out our subscripts and write this in a simpler form. So we'll do that. I know my 3's can cancel. They're 1 to 1. And I'm going to write my formula as AuPO4. Gold 3 phosphate. Now what's important here to note is that 4 is below the O. Okay, so that's a correct answer. Let's box it off. So how long are we going here today? Let's see where we are. Oh boy, I'm really using some time here. It's 13 minutes. This is going to be a long one. I apologize for that. But this stuff is definitely kind of tricky. So let's take a look at another set. But this time, we're going to write formulas. Sorry, we're going to write the names for. We're going to write the names for these ionic compounds with transition metals. So let's start off. This is the tough part. If you thought the last part was easy, this next part gets tough. So let's take a look at the first one. It's FeCl2. All right? So we're trying to find the name of FeCl2. There's a procedure to this. We need to use some relatively simple algebra, but if you don't get it and you don't use your periodic table, you're going to have to practice, all right? So the first thing I do when I do this is, and do follow along with me on your examples on your worksheet, the first thing I want to do here is divide my compound in half. I divided my compound in half. Cation on the left side, anion on the right side. Next thing I want to do is I want to identify the charge of the anion. Chlorine is in group 17. It's got a 1 minus charge. Now, iron, on the other hand, is a transition metal. It can take two or three different charges here. All right? So in this case, I can't be sure of what my charge for my iron is. So I have to do some math to figure it out. So what I'm going to do here, above the iron, is I'm going to put an X. That X represents the unknown charge. All right? Next thing I want to do is count up how many of each type of ion I have. I'm going to start with the anion. All right? There's 2 chlorines, 2 chlorines, 2 chlorines at 1 minus each. So I'm going to write 2 1 minus values, or minus 1 values. All right? So I'm going to write minus 1 and minus 1 because there's 2 chlorines. Now, how many irons do I have? Well, there's no subscript, but there is the symbol. So I have 1 iron. So I'm just going to write 1, and I know that this iron's charge is unknown. Okay, so we know we have to figure this out, but I have 1 iron. So now the next thing I'm going to do is this. I'm going to draw another line. I'm going to put the 1. I'm going to bring that X down and put it right next to the 1. We're solving for that unknown charge for the iron. I'm going to put a positive, I'm going to put a plus sign. Then I'm going to add up my 2 anions. -1 plus -1 is -2. And I'm going to set that equal to 0. And the reason why I set it equal to 0 is because all balanced chemical formulas have an overall charge of 0. Now I'm going to solve for X, right? I'm going to solve for X. So when we solve for X here, all we have to do is add the 2 here and add the 2 here. And we know that X equals +2. Therefore, iron's charge is 2 plus. Iron's charge is 2 plus. So what do I do next? Well, I write the formula. So iron is, Fe is iron. Fe is iron. Its charge is 2 plus, so I write the Roman numeral 2. I know what chlorine is. It's chloride, so I write chloride. And there you have it, iron 2 chloride. All right, let's do another one because these are tough. Okay, so let's take a look at the next one. The next one is going to be Cr2O3. 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 Now, same thing again. Divide it in half. Identify the charge of the anion, 2 minus. Oxygen's in group 16. Unknown charge for the chromium. Remember, transition metals, you don't know what their charges are until you do some math. It's X. How many oxygens do I have? 3. Right? 3 at a 2 minus charge each. So I got that 2 minus, or minus 2, 3 times. How many chromiums do I have? I have 2 chromiums. I had 1 iron before, but now I have 2 chromiums. 2 chromiums. So I'm going to put a 2 down. Okay? Now what I'm going to do is I'm going to draw that line. I'm going to write my 2 for the 2 chromiums. I'm going to bring that X down. I'm going to put an addition sign. I'm going to add up my anions. -2 plus -2 plus -2 is -6. Set it equal to 0 because all chemical formulas have an overall charge of 0. Solve for X. First add 6 to one side, and then add 6 to the other side, and then solve for X. Let's do this. So you have 2X equals +6. So X will equal 3. That tells me that chromium's charge is 3 plus, right? Chromium's charge will be 3 plus. So let's go ahead and write that. Chromium, 3 for that +3 charge we got, and it's oxygen, so it's oxide. Chromium 3 oxide. All right, that one's right. Let's do one more, and then I'll shut up because I know how little you like to listen to me talk. And we're already at 20 minutes, so we're really digging into some time here today. But hang in there, and I'll be finished shortly. So the next one is going to be Ti3SO4. Okay? Ti2SO4 3. Okay? A little bit more complex here. For this one, we have a parentheses to represent 3 polyatomic ions, right? And we have a polyatomic ion in the middle, different than the last 2 we did. But we can handle this because we do the same process for this as we've done for the other ones. First thing, divide it in half, ending where that cation ends. Put a line. Identify the charge for the polyatomic ion. Sulfate on the polyatomic ion chart has a 2- charge. 2-. Titanium, transition metal, unknown charge. Put it as an X. How many sulfates do I have? Well, it's represented by the parenthesis with a 3 underneath. I know I have 3 sulfates, each one with a -2 charge. So I'm going to put that 3 times. -2, -2, -2. How many titaniums do I have? Subscript tells me there's 2 of them. I'm going to put a 2 down. Good so far. Last step in the process, like we've done before. I have 2 titaniums with that unknown charge of X. Put the addition sign in. Sum up my anion charges. -2 plus -2 plus -2 is -6. Set it equal to 0 because all chemical formulas have an overall charge of 0. Solve for X. X again equals +3. Next step in this process is to write the formula. I have titanium 3 sulfate. Titanium 3 sulfate. And that's the name. That's the name for Ti2SO43, titanium 3 sulfate. All right. So once again, a stellar lesson by your favorite chemistry teacher, Mr. Donnelly. And you know what? You love it.